when we burn something, we call it combustion. Okay, if we take methane, let's say, it makes carbon dioxide and water. But there's one more thing that it gives off that we don't talk a lot about, and that's heat. Okay. In the combustion and burning, we have carbon dioxide, water, and heat is always the energy. So energy, with the first law of thermodynamics, energy is conserved. Second law says energy is dispersed. Okay. So because it's conserved, methane has stored energy, or what we call potential energy. With an igniter like a flame, it will burst into flame, producing carbon dioxide and water, and giving off energy in the form of heat. Okay? In this way, combustion is, if heat's on the right side of the chemical equation, we call that exothermic, or heat is given off. Right? Exothermic, heat's given off, so we feel hot. And how do we find out how much heat is given off? We measure with heat transfer from here to here. Right? And to find out the heat transfer is measured in calorie. It is given this equation: Q equals mass times specific heat capacity times delta T, which is a change in temperature. Okay, so Q is the heat transfer, or how much energy. Okay, and it's usually given in calories. M is the mass, and is usually given in grams. Okay. Cp is the specific heat. Okay. Cp is specific heat, and it's usually given in calories per gram Celsius. So let's talk about, let's say, specific heat of water. Okay, specific heat of water, CPW. It would be 1 calorie per gram Celsius, which says that to raise the specific heat of water, it would take 1 calorie of energy to raise 1 gram of water by 1 degree Celsius. Okay, so that's specific heat capacity of water. Different material have different specific heat. How well is able to absorb heat, or how well is able to transfer heat. Water is pretty slow to transfer heat compared to, let's say, metal or glass. Brass would have a specific heat around 0.09 calorie per gram Celsius, which means it doesn't require a lot of heat or energy to transfer heat through the metal. That's why if you heat up metal on one end and you hold the other end, it heats up very quickly. Okay. So it has a very low energy requirement or heat capacity. Okay. So, and then delta T would be the change in temperature, and it's usually final temperature minus initial temperature. Okay. Initial. Final minus initial. Okay. Change in temperature. So that's how we would calculate the heat transfer. So if I gave you a question, say, if I have 25 grams of water, and we can also, with water, because water has a density of water is 1 gram per 1 mil. If I have 25 mils of water, I also have 25 grams of water. Okay, it's going to be used either way because the density of water is 1 gram per mil. Okay, density divided by mass, mass divided by volume. I should say density, mass divided by volume. Okay, so if I have 25 mils of water, I have 25 grams of water. If I have 25 grams of water, how much heat would it take for me to raise it from 25 degrees to 35 degrees? Okay. So the initial temperature is 25 degrees. The final temperature is 35 degrees. Right. So how much energy? So we want to plug this in. How much energy would it take to raise 25 grams of water, or 25 mils of water, from 25 degrees to 35 degrees. So if we plug this in, okay, Q is equal to mass, which is 25 grams, right? And the specific heat capacity of water is 1 calorie per gram Celsius. So I'm going to go 1 calorie per gram Celsius. And I'm going to multiply the change in temperature. The change in temperature is final temperature, which is 35 degrees, minus 25 degrees, will give us the change in temperature of 10 degrees, right? So I'm going to plug this 10 degrees in here. Okay. And if you multiply them out, you get 25 times 1 times 10. That will give you 250, right? What unit would it be, right? What unit would it be? So when you do this, make sure you leave the grams here by itself and the calorie by itself. Don't add any number next to it. So when you do this, the grams cancel, okay, and then the Celsius cancel, leaving only the unit of calorie. So how much heat is required to raise 25 grams of water from 25 degrees to 35 degrees Celsius? It would take 250 calories. That's what it is, right? Because this Q is the measure of heat transfer. All right? So to recapture, when we burn something or combustion, it requires oxygen. It produces carbon dioxide, water, and heat. Heat is a form of energy. Okay? To measure how much energy is released, we can measure how much heat transfer. And we use the equation Q equals mass times specific heat times the change in temperature. Right? Q is the heat transfer, which is measured in calorie. Mass is in grams. The Cp, which is the specific heat of different material, has different specific heat capacity. Cp for water is 1 calorie per gram Celsius, which says that it would take 1 calories of energy to raise 1 gram of water by 1 degree Celsius. Okay. And then the delta T is the final temperature minus the initial temperature. Okay. And if we plug that in, we get something like this. So that's how you solve for heat transfer.